Good morning. Today let us complete this unit 4, that is the last concept we are going to discuss is reinforcement learning. This is one of the component of AI and is a subset of one of the machine learning technique. Already I have given some description and some information regarding this reinforcement learning when we are discussing about the machine learning. Today in detail let us discuss what is this reinforcement learning. So reinforcement learning, it's a feedback based machine learning technique in which an agent learns to behave in an environment by performing the actions and seeing the results of those actions, and for each good action the agent gets positive feedback, and for each bad action the agent gets the negative feedback or penalty. And in reinforcement learning the agent learns automatically the feedbacks without any labeled data, unlike the supervised machine learning. And since there is no labeled data, the agent is bound to learn by its experiences only. And the agent here interacts with the environment and explores it by itself. And the primary goal of an agent in reinforcement learning is to improve the performance by getting the maximum positive rewards. So what is the final agenda of a particular agent in a reinforcement learning? He has to maximize its rewards. And see this is a just block diagram of reinforcement learning. See here the elements or components of a particular reinforcement learning: agent, environment, action, state, reward. So how does this reinforcement learning work? Here first an agent is going to start in a state and it is going to take an action and receive a reward or penalty from the environment, and then is going to observe the new state of the environment and is going to update the policy to maximize the future rewards. Okay, if it gets punishment, yes, later by observing the environment it has to update the policy to maximize the reward. That is what the concept behind this reinforcement learning. And see this, the terminologies used in this reinforcement learning. One is this is the environment, and in this environment we have reward, action, what is the selection of algorithm, agent, and the state. Okay, so these are the some of the terminologies. Whenever we remember reinforcement learning, we should remember that an agent, action, state, policy, reward, punishment, and environment. These are the terminologies related to this reinforcement learning. Let us see one by one what are this. An agent or reinforcement agent or simply learning agent, all are same, and it is the sole decision maker and learner in a reinforcement learning environment. And coming to the environment, it's nothing but a physical world where an agent learns and decides the actions to be performed. And action space, a list of actions which an agent can perform. And action is an agent's single choice, like moving left, right, up, down in the environment based on the application. And then state, the current situation of the agent in the environment, where the current situation the agent is in the environment, that we call it as the state. And reward, for each selected action by an agent to solve a particular reinforcement learning, the environment gives us a reward, and it's usually a scalar value or nothing but which we call it as the feedback from the environment. And then reward function, and this is a predefined function within the RL framework that determines that how rewards are assigned based on the state of the environment and the agent's action. Based on the state of the environment and the agent's action, then agent is going to get the reward function. And policy, it's nothing but a strategy, means decision making to map the situations to the actions, that is called as the policy. And one more important one is the value function, that is the value of the state shows up the rewards achieving starting from the state until the policy is executed. Okay, starting in a state, an agent, and until a policy is being executed, the value that is called as the value function. And model, we know that every RL agent doesn't use a model of its environment. The model agent's view maps actually the state action pairs probability distributions over the states in a model. That is what. Then next, elements of reinforcement learning. There are 4 elements of reinforcement learning which are policy, reward signal, value function, and model of the environment. These are the 4 elements. Let us see one by one. A policy can be defined as a way how an agent behaves at a given time. That is, it is going to pursue the states of the environment to the actions taken based on those states. And it is a core element of the RL, and it alone can define the behavior of the agent. And in some cases it may be a simple function or a lookup table, and in other cases it may involve general computation as a like a search process. And it could be deterministic or stochastic policy. If it is deterministic policy, something like this we are going to give, where this pi of s is a function that returns the action A to take in state S, and for stochastic policy something like this, what we call it is pi of A given S represents the probability of taking action A given state S. So these are the two policies generally an agent will follow when he is performing something in the environment. And then reward signal. The goal of the reinforcement learning is defined by the reward signal. At last, what is the goal of a particular agent is to maximize his rewards. So this, at each state, the environment sends an immediate signal to the learning agent, and this signal is known as the reward signal. Either it may be a punishment or it may be a reward, but that will be sent back to the agent. That itself is called as the reward signal. And these rewards are given according to the good and bad actions taken by the agent, and the agent's main object is to maximize the total number of rewards for good actions. Okay, and this reward signal can change the policy, such as if an action selected by the agent leads to low reward, then the policy may change to select the other actions in the future. Why? Because to the main goal we are saying is, the main object is to maximize the total number of rewards. Yes, definitely, then we have to change the policy. Then value function. It gives the information about how good the situation and action and how much reward an agent can expect. So this reward indicates the immediate signal for each good and bad action, whereas the value function specifies the good state and action for the future. That is what the difference between this reward and the value function. And value function always depends upon the reward, as without reward there could be no value. So the goal of estimating these values is to achieve the more rewards. And then model. The last element of this RL is the model, which mimics the behavior of the environment. And with the help of this model, one can make inferences about how the environment will behave. That is, if a state and an action are given, then the model can predict the next state and reward. So without a model, a particular agent can't work with the environment. Now, what are the approach? So when we want to implement this reinforcement learning algorithms, we need some approaches. So that approaches are divided it into two types. One is a model based methods, other one is a model free methods. And again, in model free methods we have value based and policy based. We have already known that this value function and policy. So those all two comes under this model free. Mean without using any model, even we can go with the value based and the policy based. So here value based, it focuses on learning a value function that estimates the expected future reward for an agent in a given state under a specific policy. Okay. The agent aims is to maximize his value function to achieve the long-term goals. And the popular algorithms in this is Q-learning, SARSA, state action reward, state action, and the deep Q networks. These three comes under this value-based approach model. And this policy based directly learns a policy function which maps the given state to the action what an agent is going to take. And the goal here is to find out the optimal policy that leads to the highest expected future reward. The main goal here is, at last you have to find out, the agent has to find out the optimal policy. And the examples of this particular policy based is reinforce, proximal policy optimization, or simply we call it as a PPO, and actor critic methods. These are the some of the examples that comes under this policy based approach. And next one is the model based. Here this model based attempts to learn a model of the environment, and this predicts the next state and reward and for a given state action pair. And agent can use this model to plan and simulate actions in a virtual environment before taking them in the real world. Before taking it into real world, it will start simulating some actions in that virtual environment, and it is going to see whether any problems are there or not. And then this approach can be computationally but when we want to implement this, actually this is expensive for complex environments and requires additional assumptions about the environment behavior. That is what the small limitation or disadvantage of this particular model based approach. Then Now, the next one is types of reinforcement learning. We have two types of reinforcement learning. One is positive reinforcement learning and one is a negative reinforcement learning. In positive reinforcement learning, it is like positive behavior followed by positive sequences. If you take some example, like a manager praises the employees in a particular organization, that comes under this positive reinforcement learning. And the punishment, suppose negative behavior followed by negative consequences, that is manager demotes the employee, that comes under this punishment under this positive reinforcement. And coming to this negative reinforcement, positive behavior followed by removal of negative consequences, that is manager stops nagging the employee, is just a small example for this. And extension is negative behavior followed by the removal of positive consequences, that is the manager ignores the behavior. So this is what just two types of positive and negative reinforcement learning. Let us see in detail. So positive reinforcement is defined as when an event occurs due to a specific behavior, that is in an environment, increases the strength and frequency of the behavior of a particular agent. So it has a positive impact on behavior, how he is behaving in a particular environment. And the advantages is it is going to maximize the performance of an action, and at the same time it sustains changes for a long period. And disadvantages, this excess reinforcement can lead to an overload of the states which would minimize the result. Then negative reinforcement, it is represented as a strengthening of a behavior of an agent in a particular environment. And in other ways, when a negative condition is barred or avoided, it tries to stop that action in the future. Okay. Then advantages is maximize the behavior of a particular agent in the environment and provide a decent to minimum standard of the performance. And disadvantages, it just limits itself enough to meet up a minimum behavior. And then coming to the applications of RL, these are the different applications in different domains we can use this reinforcement learning. You see, like game playing, chemistry, finance sector, manufacturing, business, okay, robotics and controlling. See, coming to the robotics, we know that nowadays how means in a daily life how robot has become an important. So to make use of or to implement something with in robots, so RL is used, RL. And then control is used for adaptive control such as factory processor, and in the telecommunication and especially helicopter pilot is the just example of this reinforcement learning to controlling. Then game playing, we know that in online we are going to see daily many games like tic-tac-toe, chess, check-go, and so the chess, these are all can be implemented with the help of this RL. And chemistry, and even RL can be used for optimizing the chemical reactions. And coming to the business, nowadays it is used for business strategy planning, even RL. And then manufacturing, in various automobile manufacturing companies, the robots use this deep reinforcement learning to pick up the goods and put them in some containers. So for that also we can make use of this reinforcement learning. That is also one of the application of this RL. Thank you.